Okay, I also want to answer with you this question, which is 2024. Okay, paper 1, question 22a. The question is a straight line L is perpendicular to the line y is equal to 3x plus 4. Given that line L passes through the point, this one, 3 comma a, and as 3 as its y-intercept. Find the value of a. So here we have this line, which is line L. So our line L, its y is equal to 3x plus 4. This is line L. Okay, so then this line L is perpendicular. Okay, a line L is perpendicular to the line. Okay, so now this line is perpendicular to line what? L. Okay, so now if it's perpendicular to line L, we know that when we talk of gradient, we say m1 times m2 should give us what? -1. This is the principle that you're supposed to have. Okay, m1 by m2 will get what? A -1, which means it is what? A perpendicular. So here, having this line, we're going to find the gradient of this line. So finding the gradient of this line, which means we equate this line to the general formula, which is y is equal to mx plus c. Okay, mx plus c. So the gradient is this one here. So x will cancel, and then you just get m is equal to 3. So we are saying that m is equal to 3 as the gradient 1. So here in this formula, we say that our m1 is equal to 3 times another m should give us -1. So we find we'll divide throughout by 3 by 3. So this one and this one will go. Then our gradient here will be m is equal to -1 over 3, which means this answer and this one are what? Perpendicular gradients. Okay, so they are going to make what? A perpendicular line. Now the one that is going to have this line as a y-intercept of what? 3. Okay, has got a y-intercept of 3. Then so now we have already been given the values that are going to be in our what? General formula. This is our general formula, remember. So where there is y, we replace by a. Where there is m here, we replace by what? By this here. It's a gradient. Okay, so we replace by this. Where there is c here, we write 3, which is what? The intercept. So here intercept is what? C, and where there is 4, this 4, it is what? The y-intercept of this line. So the intercept of this line, it's what? It's 4. It's where the line cuts the y-axis. That is what we call intercept. So here we'll say we have the general formula, which is y is equal to mx plus c. Then having been given this points, which is 3 comma a, and our gradient here, our m is equal to -1 over 3. So we replace this one, it means x-axis, and this one is what? Y-axis. Then we have been asked to find the value of what? A. So where there is y, you replace by a. So here we'll say a is equal to, I've just replaced where there is y, I've replaced what? A is equal to, where there is m, we replace by what you have been given here, which is -1 over 3, what you've calculated. So here we'll say -1 over 3. Okay, then open here, you open bracket. Where there is x here, you replace what you have been given. The value of x here is what? It's 3. So here you say 3. you close bracket plus. So your intercept here, you have already been given that your intercept is what? It's this 3 here, it means the intercept. So where they see, you replace by 3. Okay, so this is what we have. So having this, we can work out this 3 there, it's 1, 3 there, it's 1. So we are going to have A is equal to -1 plus 3. Then our A here is going to be here. These two are different what? Signs, so it means we subtract and maintain the sign of the big number. So here is going to be 2, which is positive. So our A is equal to 2. You get the full mark. Okay. Question 22b. The diagram shows a sketch of the graph of a curve passing through A, which is -5, 0, and B -1, 0. So now I have this sketch here, which is not to the scale. Okay, so now here in this sketch we are asked to find the equation of the function and also the coordinates of the turning points. So having this, remember this is x-axis. Okay, so this x is equal to -5. So we say A here, we are saying that our x is equal to -5. Okay, then also we have this point here, which is our x is equal to -1. So having something like this, which means we are going to use the formula of what? Reversing these two what? Answers into an equation the way it was. Okay, remember these are answers, so now we're going to do a reverse way of answering. So having something like this, which means we're going to transpose this to the other side, then it's going to be our x. This is positive, this is negative, so once it goes this side, it will be what? Plus 5 is equal to 0. This is the way it was. Then again here we have our x plus 1 is equal to 0. So having something like this, which means we can multiply this and this. Okay, we can multiply because this one, it will be as the difference of what? 2 squares. So having this one, it's going to be something like our x. Here we say x plus 5. We close bracket. Then we also open x plus 1, we close, is equal to 0. Okay, so we are putting them together. So here we'll say this one by this, it will be x open bracket, x plus 1, we close, then plus 5. Here this 5 is this one, that will get 5, x this one plus 1, we close, is equal to 0. So this is the way it was. So we are answering this in a reverse form. Okay, so having something like this, which means we can multiply throughout by this x times this, we are going to have x squared. Then this and this, we are going to have plus x. Okay, here it's plus 5 by x. Here we are going to have 5x. Then this and this, we are going to have a plus what? 5 is equal to 0. This is what we are going to have. So having this, we know these are like terms, we can add them. So we have x squared plus 6x plus 5 is equal to 0. So here we can end at this point, okay, where we'll say our y is equal to this, which is the function. Now here again, to write the final answer, you see the nature of what? Of the curve. Okay, so the nature of the curve, this one is what? It's a maximum curve. So this curve has got a maximum what? Turning point. So since this one has got a maximum turning point, we say that here our a should be less than what? 0. So when the a is less than 0, you need to know that it is what? It has a maximum turning points. So here we are going to multiply throughout by what? By a negative sign. So we are going to multiply throughout by a negative sign. So once multiplied by a negative, which means this one will be, we introduce what? A negative. Okay, so the reason why we are introducing a negative is to make sure that this equation qualifies with the skate where this skate has got a turning what? A maximum turning points. This is the reason why you are doing that. So we say this times this, we are going to have a negative x squared minus 6x minus 5 is equal to 0. Y is equal to negative x squared minus 6x and then minus 5. So this is what? The equation of this curve. Okay, then from there we can also calculate the turning points. So calculating the turning points, we have this formula. So we are going to use this formula, which is b. Here we are saying that the coordinates of the turning points, we have negative b over 2a, comma. Okay, so here we for y, this is for x. Okay, so for y we say it's 4ac minus b squared then over 4a. So this is the formula for the turning points. This is the formula for the turning points. Remember, turning points are coordinates. Turning points are coordinates. So having this here, we are saying that our equation is y is equal to negative x squared minus 6x minus 5. So here we write the general formula. It is y is equal to ax squared plus bx plus c, where we say our a is equal to negative 1. The coefficient of x squared dx squared is negative 1. Then here the coefficient of b here, it's just what? Negative 6. Again, c here is just what? Negative 5. So having this, we replace in the given what? The formula. So we say, which is the turning point. Okay, TP is equal to negative, where there is b, we write by negative 6. So here it's going to be negative 6. Okay, b here is negative 6. So say negative 6. We close over to 1. Okay, negative 1, sorry. So here it's negative 1. Negative 1, comma 4. Our a here it's negative 1. Then c, it is also negative 5. Then minus our b here is negative 6. Then we square over 4 negative 1. So this is what we have. So having this, just a matter of manipulating this. We don't use a calculator. Remember, negative times negative is positive here. So we are going to have positive. So it's positive 6 over there, and there we are going to have a negative what? 2. Here we are going to have a negative 2. So negative 2 here on top is going to be a negative. Then close bracket. Then here it's 36. So this and this, we are going to have a positive. Negative times negative is positive. Then for there we are going to have a positive what? 20. So we are going to have 20. Here it's negative. This is positive, so we are going to have negative 36. Then over negative 4. This and this is negative 4. We can close bracket here again. So this one we can work out. This into this, we're going to have negative 3 here, comma. negative 3 comma, okay. Here we are going to have negative 16 over negative 4. Then this and this, what are we going to have? We are going to have negative 3 there. Then this is going to have positive 4. Okay, we are going to have a positive 4. So this is our coordinates for the turning points. Okay, this is the coordinate of the turning points. So here, what has makes us to qualify these coordinates as negative 3 comma 4, it's the way the equation is what it's turning. So as you can see, this is y-axis. So this is y-axis where we've got y positive value is what this side is what positive value, and this side is what negative value. Then here we have there is what there is what negative 3 somewhere there. Okay, then here is what positive. So whenever you see the value of y determines the nature of the graph. Okay, the value of y determines the nature of the graph.